we will look at permutations. First of all, the definition of a permutation. A permutation is an arrangement of objects in which order is important. So when we talk permutations, order is very, very important because we are arranging objects. So when you arrange things, you arrange them in some kind of order. So that is the meaning of a permutation. And the letter P shall be used in this section for permutations. Later on, we will study combinations, and so we shall be using the letter C. Right, there are certain rules that we need to learn. Please find an effective way of learning these things. I find it easy to understand these rules by maybe applying them in examples. You don't have to memorize the rule, but just make sure that it makes sense to you. The rule on its own may not make sense. It says the number of arrangements of n distinct or different objects taken in n ways is given by that thing there. That symbol there is n factorial. I will explain what n factorial means. I'm talking about this here. That is n factorial. This n with an exclamation mark. It means n factorial. Maybe let's explain that now. N factorial means you are multiplying your numbers in descending order. These are whole numbers, not whole numbers maybe, but natural numbers, the counting numbers. And so starting from n, you're multiplying these numbers right down up to 1. As an example, 5 factorial means 5 is multiplied by 4, multiplied by 3, multiplied by 2, and multiplied by 1. So you're multiplying the natural numbers from 5 right up to 1. So that is what we mean by the factorial notation. But let's look at examples so that this thing makes sense. Here is example 1. It says how many arrangements. You see, those are arrangements, which means we're permuting. So how many arrangements can be made using all the letters of the word unbiased? You know, those letters can be rearranged. I know right now it makes a lot of sense. It's U, then N, then B, then I, A, S, E, D. But we can scramble those letters and start with any one of those. So how many different arrangements can we make? We could be forming words, but maybe some of the words are meaningless. They don't make any sense. Right. So how many arrangements or different arrangements can we make using the letters of the word unbiased? Okay. First of all, please take note. There are 8 letters there. If you count, we have 8 letters in the word unbiased. And so we need to use all the letters, which means we are forming, if you want, we are forming kind of words that have 8 letters. So you can think like this: 1, 2, 3, 4, 5, 6, 7, 8. Right. Using those letters, we know that any one of those letters can take the first position. So we can put any letter in the first position. But how many letters do we have there? We said we have 8. So that will be 8 different ways of filling up the first position. Now that the first position is filled up, we are left with 7 positions. 1 letter has been used because we are not going to repeat this letter according to the questions. We're not going to repeat the letter, but there are questions where the letter can be repeated. In this case, the letter that took the first position is no longer going to be used. So now we are left with 7 letters and 7 positions. So this position here can be occupied in 7 different ways. Right, so up to there, you will notice that 2 letters are used, which means we are left with 6. Now we need to fill up the third position. So the third position will be filled up using the remaining 6 letters. And so any one of those 6 letters can be used. So we have 6 different choices for the third position. Similarly, we have 5 different options for the fourth position. Then we have 4, 3, 2, 1. So this is how we are filling up the positions. Now the number of arrangements you can get is then found by multiplying these numbers. So these numbers should be multiplied by each other. Multiply all these numbers by each other. Now you will notice 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is what we call 8 factorial. Now 8 factorial is not simplified. You actually need to simplify that if you need to simplify, unless the question says leave your answer in factorial form. I didn't give you the spelling of factorial. I wonder whether it is there. This is what we are talking about. That exclamation mark means factorial. So 8 factorial, you can multiply that. I want you to check in your calculator if this is your first time to use the factorial notation. Look for that function. You should find it somewhere and use it to work out your answer. So in your calculator, you will input your 8, because this is 8 factorial. You will input your 8, then shift, then I think you will see that one there where there is x to the minus 1. That will give you the factorial of 8. So 8 factorial is equal to 40,320. What this means is, using the letters of the word unbiased, we can actually form 40,320 different arrangements. There's quite a lot. Let us look at example 2. It says 6 students, so there are 6 students. Alice, Bossy, Carol, David, Ed, and Fasto. They are asked to stand in a line. So these 6 students are asked to stand in a line on stage. And we want to know the number of different ways in which they can stand in a line. Remember, these people are just standing in a queue, and they will obviously be standing next to each other, but who is standing next to who, and so on and so on. So that can keep on changing. So we are saying, can we look for the possible number of different ways in which these people can be arranged in a line? Right, so we are using the same method. So there are 6 students. It will help you to think like this. I know that you can tell that the answer is 6 factorial, but there are 6 people here, which means there are 6 positions that have to be filled up. So the first position can be taken up by any one of these 6. So there are 6 different ways in which we can fill up the first position. Now that the first person is standing in the first position, it means there are 5 people that are left. And so any one of those 5 can actually fill up the second position, which means the second position can be filled up in 5 different ways. The third position will therefore be filled up in 4 different ways. The fourth one will be filled up in 3 different ways, that one there in 2 different ways, and that one there in 1 way. Now, these numbers should be multiplied by each other. Now, you are doing it like this because you understand what is happening. So I like this approach because you kind of have an understanding instead of just putting things into a formula, you do this. So now 6 times 5 times 4 times 3 times 2 times 1 is what we mean by 6 factorial. And so you can use your calculator now to work out 6 factorial, or to multiply out 6 times 5 times 4 times 3 times 2 times 1, and that will give you that answer there of 720. So these 6 students can actually stand in a queue in 720 different ways. That is quite amazing.